Hi and welcome to this video on probability, permutations and combinations. We're going to just cover this quickly. In permutations the order matters, in combinations the order doesn't matter. This is the formula we use for permutations, which is n factorial divided by n minus r factorial. All we mean by factorial, say we had 7 factorial, that'd be 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 7 factorial. So here we've got a team of 7 long distance runners. How many different ways can the first 3 places be filled? So we've got the first 3 places, so the order matters. This is going to be a permutation. If we want to do it manually, it's 7 times 6 times 5, which gives us 210 ways the first 3 places can be filled. Using the formula, we get 7 factorial divided by 4 factorial, which again just becomes 7 times 6 times 5, which is 210. We've got the same team again of 7 long distance runners. How many ways can a team of 3 be chosen from the 7 runners? Here the order doesn't matter, so it's a combination. The formula for finding out how many combinations there are is n factorial divided by n minus r factorial multiplied by r factorial, or NCR in your calculator. And when we put that into use, that formula, we get 7 factorial divided by 4 factorial multiplied by 3 factorial, which equals 35. Probability is how likely something is to happen, or the chance of something to happen. We can use a probability scale, which is a linear scale, to show this, where 0 is impossible and 1 is certain, and there's sort of a range in between. So 0 would be like throwing a 7 on a die, that's impossible. Over here, unlikely. Throwing a 6 on a die, that would be unlikely. Throwing a head or a tail when we flip a coin, that would be an even chance. And certain, that it's going to be cold at Christmas, or it's going to rain in Manchester. Probability is the events divided by the number of outcomes. So here we're going to roll a die. The probability of rolling a 3 is the events is one event, which is the 3, divided by how many outcomes we could get, which is 6 faces, all with different numbers on, which is 6. So the probability of throwing a 3 is 1 divided by 6. We can show this as a decimal, so we divide the 1 by the 6, or we can show it as a percentage. The probability of drawing an ace of hearts out of a pack of cards is 1, because there's only one ace of hearts out of a pack of 52 cards, so 1 divided by 52. The probability of drawing a club, the number of cards that have a club on them are 13 in a pack of cards. Total number of cards, or the number of outcomes, is 52. So the probability of drawing a club is 13 divided by 52. In probability, independent events are mutually exclusive. For example, when we roll a die and we roll a 5, that's 1 divided by 6. Rolling another 5, that again is 1 divided by 6. So these events are independent, mutually exclusive. Probability events can also be dependent or conditional, and these depend on the previous events. So if we're drawing a club from a pack of cards, so drawing the first club would be, like we discussed, 13 over 52, because there's 13 clubs in a pack of 52 cards. However, when we're drawing another club without replacing the first one, this becomes 12 because we've already taken one out. So 13 becomes 12, and the 52 has been reduced by 1, 51. So drawing another club without replacement, 12 divided by 51. Probabilities and odds, if we're given the odds of something winning or a horse winning, is 9 to 4. So the win is 9 and 4. The outcomes is 13, and the probability of a win is 9 divided by the total number of outcomes, which is 9 plus 4, 13. In probability, we can use probability trees, and these provide a systematic method of generating the elements of a sample. It's easy to determine the probabilities from a probability tree. The root of the tree, which is here, is the starting point, and it's connected by lines to a node. So these lines are also called branches. Each node is a different outcome, and nodes can be connected to other nodes for the next outcome. So each branch is labeled with the probability of that outcome. So like in this example, we've got a bag, and in the bag there's 3 red balls. Sorry, there's 2 red balls, there's 3 green balls, and there's a white ball. So the nodes are red ball, green ball, white ball. The total number in the bag, or the number of outcomes, is 6. So that's divide by 6, divided by 6, divided by 6. And there are 2 red balls, 3 green balls, 1 white ball. When we add these 3 fractions down, the sum of the 3 probabilities is 1. So that's like a double check to make sure we've done it right. Each branch is labeled with the probability of that outcome. So in this example, again, we've got 2 red balls, 3 green balls, and white ball. 1 ball is chosen in turn at random, and then the ball's not replaced, it's not put back in the bag, and then another ball is chosen at random. So here we draw our tree diagram with our lines are our branches, and then we need 3 other nodes, and then each one of those has 3 branches, and each one of those has 3 outcomes: red, green, white, red, green, white, red, green, white. Then we need to fill in our probabilities. Here our probabilities were the same as before, which is for the red 2 out of 6, for the green 3 out of 6, for the white 1 out of 6. But here we have conditional probabilities because we've removed 1 red ball, then here we've removed 1 green ball, then here we've removed 1 ball, which is white. So here the conditional probability, because we've removed 1 red ball, would go from 2 to 1, and the total number would go from 6 to 5. So the probability of getting a red and then a red by the multiplicative law of probabilities would be 1/5 multiplied by 2/6. So getting a red and a red, we go along this path and multiply the probabilities together. Here at the green branch, we've taken 1 red out, but we haven't taken the green out, so the green remains as 3. And the total number, because we removed red, is 5. Okay, here we've still got one white ball, but the total number inside the bag is 5. And we go along. When we've done this when we multiplied these 2 fractions together, okay, write them down, and a double check to make sure you've done it right is to total up this line here, and the total should equal 30 over 30, which is 1. Each different path in the probability tree represents a mutually exclusive event, and we have what's called the additive law of probabilities. So what's the probability of no red balls being selected? So on our probability tree, we mark off where there's no red balls, so there's no R's here, no R's here, no R's, there is an R there, there's no R's here. Mark those off and then add those probabilities together. So that'll be 6 divided by 30, 3 divided by 30, and 3 divided by 30. And then we add those, and that equals 12 divided by 30. So getting no reds would be the probability would be 12 divided by 30. Got a jar containing 2 green and 5 red sweets. We're to randomly select sweets from the jar without replacement until we get a red sweet. So again, here our first node and the 2 branches from node. We'll get a red and a green. We don't carry on further with the red because we've got the red sweet and that's what we wanted. So this would be 5 out of 7 and this would be 2 out of 7 as the probabilities. Then the green we can go further because we haven't selected a red. We go again 2 branches from that node, from the green node. Here we get for the red 5 because there's still 5 reds in the jar, but our total number of sweets has gone down to 6 because we've drawn a green sweet out of the jar. So this probability would be 5 out of 6, and then we stop there because we don't have any nodes or further nodes. We don't go further, no branches from there. But here we can go further because we've still got 1 green sweet which we can draw out of the bag. The probability of that is 1 over 6. We don't go any further because that will become finished. The green sweets are finished in the jar. But from here we can go further. So there's 5 and the total number has gone down to 5. So chances or the probability of choosing a red sweet, 5 divided by 5. Probability and statistics, how we can use probability. What is the probability of a randomly selected voter favouring Brexit, which is leaving the European Union? The number of Conservatives are 40% of voters, 35% are Labour, 25% are UKIP. Notice that this adds up to 100%. Of this percentage of voters, 45% of the Conservatives are in favour of Brexit, 25% of Labour are in favour of Brexit, and 25% of UKIP in favour of Brexit. Draw our tree diagram. The percentages we can write as decimals, so 40% becomes 0.4, 35% 0.35, and 25% 0.25. This adds up to 100, or 1 as the case may be. And this is C for Conservative, Labour, UKIP. Now we're told that 45% are in favour of Brexit, so that makes 55% no. 25% are in for Labour are in favour, which makes 75% no. 75% are yes for UKIP, let's leave Brexit, so that makes 25% no. Mark off our yeses, so this is yes, we want to leave, yes, we want to leave, yes, we want to leave, and then follow the branch down, or this route to the yes, and this route to the yes, and then this route to the yes. So this would be 0.45 multiplied by 0.4 plus 0.25 multiplied by 0.35 plus 0.75 multiplied by 0.25. And that's the probability that the voter we've chosen at random will favour Brexit. Just going to go over a question that fooled a few people. There's 6 orange sweets in a tin containing n sweets. The probability we're told of picking 2 orange sweets, one after the other, is 1/3. So the sweet isn't replaced. And the total number of sweets in the jar is n. So there's n number of sweets, and we've been told that we need to find n. So remember, in our conditional probability, we go along the branch. So the first one, our probability would be 6 divided by n multiplied by 5, reduce the 6 by 5, divided by n minus 1. So the bottom number goes down by 1 equals, and we're told 1/3. So this is the probability. So then we just multiply these two fractions. 6 times 5 is 30. N multiplied by n minus 1 is n squared minus n, and that equals a third. So take this n squared minus n to the other side. 30 equals 1/3 n squared minus 1/3 n when we multiply out this bracket with the 1/3. 90 equals n squared minus n. Rearranging, 9 squared n squared minus n minus 90 equals 0, which is a quadratic. When we solve the quadratic, we get the roots n minus 10 multiplied by n plus 9, which makes our solutions 10 and minus 9. So the solution is 10, n equals 10.